We're back now to complete this part of the puzzle, which is basically perform the query against the data that we just persisted in our vector database, right? So let's dive in the code. Before we implement the query, I want just to do some cleanup here. I want to prepare. I'm gonna move this data related stuff into doc search. Let me think if it didn't make sense. So everything related to doc search would be inside there. So the persist and the prepared data. Here, I'm gonna just create another file here, which will be load data. And this load data would basically be and the main. I will basically copy exactly what's here into this guy with importing core doctor persist. Yeah, so basically that. I try to run it. It is not working properly because this is supposed to be for the yes, worked. So that's the first thing. The second thing I want to do is to create before an important point here. It is when I was preparing this class, I noticed that I needed to run this create index multiple times. So I'm now dropping the existing index and recreating it again. So we have now dropping the existing index and recreating every time that you run that persist data. Okay. Now let's start implementation of our query, which will be basically query. And in our query, we are going to start by the first thing we are going to do, it is basically create a connection to the Redis, right? So Redis on, and we're going to Redis dot from URL, and then we're going to get the existing config, Redis, this URL here. So that is import Redis. And yeah, so next step is to create a function to perform the search. Let's say def tier docs, let's say. But then we're gonna accept the tags, or we can call this apps, and get the vector. And we'll also has the limit of record that we're gonna return. So in this, we're gonna basically create a query. So I'm gonna do this in another method. And create query vector, and I'm gonna pass number of results, basically number of results gonna be int, and we're gonna also pass the tag that we want to search by, and this tag would be of time. I don't know. Next string, it come as a non. really need to pass it. Okay, so I'm gonna create few variable names to document what it is each thing. So we're gonna first define what field you want to return. I'm gonna return everything. So return fields, and I want to return item ID, title, text, vector score. Yeah, it's correct. Fields. We're gonna have the search type. Search type will be NN. It's algorithm to perform some query. Let's have very quick what is that. So it's nearest neighbor. It's a supervised learning classifier. That is basically find what is closer to a given point. It is basically going to give our vector and we're going to find what is closer to that vector. What else? What next? We'll need to tell which the name of a vector that we're gonna perform the query against, which would be, let's say, let's name it vector field name. Then we're gonna have a tag query equal to star. Then we're gonna check if there is a query. If there is a tag, you're gonna build a tag query with that tag, which will be at app. Let's see if it works on 3. This is the structure, expected structure. Then we are gonna build now our query, base query. It's equal to gonna be tag query. This is a very much a Redis syntax. It's pretty awkward, so I'm gonna just copy what I have here and just go through that rather than have to type everything. So basically, we have this tag query that you just define it here. Would be asterisk, would be like a star. If there is none, it's passed. If there is something passed, we'll build that query like this, and then we'll give our search type, which is KNN, and number of results that we're going to be passing. Then the vector field name, so it's basically passing here again, vector field name, and we will then pass a variable with this vector as a parameter, and we'll return this vector score. And it's basically that. So then we're going to build our query object, which will be query will be base query. Then we'll set some extra parameters to the query. Let's see all the options. This is the one query. So we're gonna sort by vector is core desk. Like this one. We'll have return fields would be our return field that you defined, but you're gonna have each one set here. Then we're gonna have a number of limit that you have set. It could, and we're gonna say Actually, limit doesn't exist. And CPI is not really another thing that we want to do. It is basically paginated. Gene paging number of result. That's how I set the limit. And we're gonna say dialect. So number of vector I don't think ask vector score, which is the same we have set here. We're gonna print this here to see what it's actually doing. We can print the query get cards, and we can print the query string itself. And we return the query itself. So that's the query. We're gonna pass the limit as number result. We're gonna pass the app as text. Basically that. No. Vector. You need to prepare the vector first. Vector needs to be prepared, which it is. You need to transform it in a NumPy array. Vector bytes. So then you transform in a NumPy array 32, which matches with what you had on our index, and you are then converted to bytes. And you have vector, and then you're gonna pass the vector Redis on let's go the in the and then you third query vector, vector byte query. Okay. Let's see if we have it vector byte. I'm passing this vector byte to the parameter. We should be passing it as a query parameter. Vector param as vector. So this vector param here is what we have set here, that they will be the variable that will be passed on the search itself. So it's a kind of, let's say, templating query. You can just populate the parameters as part of the query itself when executing the query. This should just return search docs. Hope I have it correct. Now we need to call this search docs from our API. We have a docs API. Let's just call it here. Search docs. And then what is this about? First app will be the tags. And then I will put the vector. And we need to create the vector. So we need to call our LLM service to create embedding. Let's pass the query here. So we'll need to import that. Let's do it here. Vector. Yeah. And we should take the response. Resp. The Let's see if it works. Now go to our API, search, and I'm gonna put the text here. Help me to create a new app. And it didn't work. Let's have a look why it didn't work. Server. Let's just reload this. Syntax there at offset near chat. So go back to the query. In the query, I will comment out this part. This is the issue. That again. Yeah, there we go. We need to fix that part, but we can now query. And you can see that based on my question about create app, we have returned few document. And you can see that the first document, it is create application. And here all the information that is necessary to create a new application through this, our project. And then the next one would be the edit application. And they want another document about documentation itself. But yeah, you can see that the query, it's working fine. We just, it's not working the tag. Let's just see if we can very quickly find the issue. If not, I will try to solve it on the background. Query doc. Let's try to remove this guy. And yes, it worked. So the problem was that I have this in here. So demo in chat. If we let's just replace the tags with something dynamic as well. Let's just copy the back here and tags. And it will still working. Let's see if we do a tag that doesn't exist. I think these two tags I said not found. Yes, so it's using our tag. So tag in our docs we don't have not found tag. So we need to have a tag that is known. Otherwise it would not work. So let's just look very quick at the query itself. So basically we are building this strange query that it's read the syntax. We need to really dig into the documentation to see what it is each thing, but that's all we need for our purpose. So we have the option to do a, let's say, query or filter by tag, which is only pass the tag and the list of tags that we want to consider. And then we have another area that we need to pass the vector itself. And have to say with the fields we want to return, which are the fields that we see in our response. Let me just put it back. So vector score, title, text, and the ID itself. So with this, we conclude the query side of things. We have this part working. Next phase, we'll just get this data and pass to the OpenAI API with some more prompt engineering, and we'll in the end get the response that we want in the end, which is a proper formatted instruction to render the UI that the user need based on the user intent and the user input. Okay, see you in the next lecture.